We are now starting example 2, which is involving graphing the absolute value function and all of its transformations. This is one of my favorite things to do. I'm super excited to get working on this example. So, when we graph the transformations, we're always going to go back to our standard form for transformations. We're always going to ask ourselves, is our value an A value, an H value, or a K value? And once we know that, we kind of know what the graph does, and we can move it on the graph ourselves or find values using a table to figure out what the new graph's values will be. So the first absolute value function we'll be dealing with is y equals -2 times absolute value of x minus 3 plus 5. So, whenever you guys graph transformations, we always start with the parent function. Always. That will always be your first graph. And we're going to be graphing each transformation separately. I do not want you just to graph the final graph. So, where we always start, the very first step is to graph the parent function. Which the parent function is the most simplest form of our absolute value equation. So basically the parent function, if I were to remove all the numbers from my equation, that will give me the parent function. So if I remove the -2, the -3, and the 5, that will leave me with y just equals the absolute value of x. So every single time you guys graph these functions, we always start with the parent. And we always use the same values we did earlier in class. So whenever I graph the parent, I make my little table so I know the values I'll be plotting. We always use -2, -1, extend that more, 0, 1, and 2. Those are always the values we use. And all we're going to do is take the absolute value of all of our x's. So the absolute value of -2 is a +2. The absolute value of -1 is a +1. The absolute value of 0 is in fact 0. The absolute value of 1 is a 1, and the absolute value of 2 is a 2. So those are always the x and y values we're going to be using when we plot our parent graph. And we'll be graphing all the graphs on this same coordinate grid. So first, I'm going to graph my parent function. So I have my first points at -2, 2. My next point is at -1, 1. My next point is at 0, 0. My next point is at 1, 1. And my final point is at 2, 2. Now technically the graph does keep going on for forever, so when we connect our dots, which is do your best, when you connect your points, you do need to draw the little arrows to show that it does keep going in that direction for forever. So this one is our parent function. That's our first graph. Now, when you start to determine what the graph does based on each value, we're going to do this one at a time. Now, the next value you always have to do first is our A value. This is very important. You must always start with the A value. So, I need to figure out which of these numbers is the A value. So, the A value is the number in front of your absolute value bars, and it's the very first thing you see right after the equal sign. So right after the equal sign, the very first thing I see is -2. So what we're going to be doing, we're going to be building onto our function and adding one value at a time, and that will make the graph do different things. So the second thing I'm going to do is deal with the A value. So I'll label this as 2. The second thing we're doing is the A value, which our A value is -2. And the function we're going to deal with is y equals the A value, because the A value comes first, -2 times the absolute value of x. So all I did, I started from here and I just added on one more piece to my parent function, which is my -2. So I just put a -2 in front of my parent function. So now we're going to be dealing with these values. So what we're going to do, we're going to make a new table to determine what our new y values will be. Okay, which basically I'm just going to extend on this graph for the A value. So I'm actually going to extend on here Alright, and we're dealing with the same x values, but now, instead of the absolute value of x, we have negative 2 times the absolute value of x. So, what we're going to do, we're going to find new y values for this new graph. So I'm going to be using the same x values for my next graph, but now we'll have new y values, which the new y values I'm going to write over here. Okay, so the way that we find the new y values, we had the absolute value of x right here. We found what all those y values are. Now we have negative 2 times the absolute value of x. So all I'm going to do is multiply negative 2 to all these numbers. So I'm going to say 2 times my negative 2. And I'm going to say 1 times my negative 2. 0 times my negative 2. 1 times my negative 2. And 2 times my negative 2. Okay, so we already found this part, so all I had to do is multiply all the values by negative 2. So my first y value, 2 times negative 2 is negative 4. My second y value, 1 times negative 2 is negative 2. My next y value, 0 times negative 2 is 0. My next y value, 1 times negative 2 is negative 2. And my final y value, 2 times negative 2 is negative 4. So now for my new points, I'm going to be plotting these x's with these y's. So if you want to organize it a little better, you can. You can make a new table if that helps you. For your x values and your y values. So my x values are negative 2, the same as before. Negative 2, negative 1, 0, 1, and 2. And my new y values are these listed on the far right hand side. So I have negative 4, negative 2, 0, negative 2, and negative 4. So these will be the points that I'm plotting for my next transformation. And what's going to happen, before we graph it, we can already predict what's going to happen. So with this negative 2 for my a value, remember if it's a negative a value, the graph will reflect over the x-axis. So what's going to happen, I guess I'll write it right here. So this graph will reflect over the x-axis. And if we take the absolute value of negative 2, that will give us a positive 2, which 2 is larger than 1. And remember, anytime an a value is larger than 1, it will vertically stretch. So it's going to stretch out, which will make it more narrow. So this will be a vertical compression. So it'll vertical compress and vertical compression. And it will vertically compress by a factor of 2. So that means it's going to grow at a rate 2 times faster than what it originally was. And I just got that number by taking the absolute value of negative 2. So this is what the graph's actually going to do. So if you want to box that in, that's kind of what the graph will do so you don't forget. Alright, and now what we're going to do is to graph that. So over here, I'm going to say negative 2, negative 4. That's my first point. So negative 2, negative 4. Alright, my next point is at negative 1, negative 2. My next point is at 0, 0. My next point is at 1, 2. And my final point is at 2, negative 4. So if you notice, the graph did flip over the x-axis and it did get a little skinnier. Okay, it's kind of hard to see, but it did get a little thinner. Alright, so that is the a value taken care of. Yeah, my a value is done with. So now, after you tackle the a value, it really does not matter what you do next. You can do the h or the k. You have to do a first, but h and k, it really doesn't matter the order. So, to make things easier, I'm just going to go from left and right. So the next thing I'm going to tackle is my h value, which the h value is the number that's added or subtracted to my x value inside the absolute value bars. So that's going to be my minus 3. So all I'm going to do, I'm going to add on to this equation, and I'm just going to add on my h value, which is a -3. So step number 3. So I have y equals -2 times the absolute value of x. That's the part I've already dealt with. And the only thing we're adding on is this -3. So after we do this, the only time you have to make a new table is with the a value. Everything else you can directly move on your graph. It's pretty exciting. You don't have to do as much work for the h and the k value. You get all the work done with the a, and h and k, you just fly on through it. So before we graph this thing, I'm going to identify what this is going to do. Now remember, for the h value, you must think the opposite. So we know that the h value, it's associated with an x, because I'm adding or subtracting to an x, which x values on our graph go left to right. So I know it's going to go left and right, but remember, with the h value, you have to think the opposite. So although it's -3, we are going to go right 3. Don't let the demon cats tell you that it's going to go to the left. So we're going to go right 3 spaces. And this is an h value. Okay, so we don't have to make a new table of values for the h value. All we're going to do, we're going to start from our most recent graph, which my most recent graph is this pink graph right here. Okay, and all I'm going to do, I'm going to take all my points on the existing graph and just move them to the right 3 spaces. So I'm going to start here. I'm going to take this point and move it over 3 spaces. So I'm going to go 1, 2, 3. I'm going to go to my next point on my graph, and I'm going to move it over 3. So I'm going to go 1, 2, 3. Then I'm going to go to my next point in the graph, which is this one right here. I'm going to move it over 1, 2, 3. Alright, I'm going to take this point and move it over 3. So 1, 2, 3. And then finally, I'm going to take my last point on my pink graph and move it over 3. So I'm going to move it over 1, 2, and 3. Bam! Like that. So all that has happened is my pink graph has shifted 3 spaces to the right. It's pretty exciting. Alright, so the last thing we have to tackle is our k value. So we've already tackled the a and the h value. Awesome. So now all that's left is our +5, which I know it's a k value because it's on the end of absolute value. It's on the outside of absolute value on the end, and we are adding 5. So I'm just going to add that onto my most recent equation, which is right here. So the parts that we've already tackled is step 4. The part that we have already tackled is y equals -2 times the absolute value of x minus 3. And the only thing we're going to add on to our previous equation is my plus k up here, or which will be my +5. So I'm just going to add on that +5. And like I said before, the only value you have to make an extra table with is the a value. From here, we can directly just do it on the graph like we do with the h value. It's pretty awesome. So our k value is associated with a y. It's on the outside of my bars. It is not adding or subtracting the x, so it affects the y. So if you remember, on your coordinate grid, the y-axis goes up and down. So I know this thing either has to go up or down. So remember, when you have a positive k value, it will do what you think it's going to do. This is going to move up 5 spaces. So this is a k value. And it will move up 5 spaces. So that's what this one did. If you want to circle these, you can. Kind of states what the transformation does. I'll leave it up to you. Alright, so I will be starting from my most recent graph, which is my purple graph. And all I'm going to do is take all my points and move them up 5. And then I'll be done. It's exciting. Alright, so I'm going to start with this point, and I'm going to move it up 5. So 1, 2, 3, 4, 5. Lands on this existing dot. I'm going to move this point up 5. So 1, 2, 3, 4, 5. Then I'm going to move this point up 5. So 1, 2, 3, 4, 5. Right about here. Alright, I'm going to take this point and move it up 5. So 1, 2, 3, 4, 5. And I'm going to take this point and move it up 5. So we go up 1, 2, 3, 4, and then a 5. So all that has happened is my purple graph has shifted up 5 spaces. So the green graph is my final graph, and it's actually, if you were just to graph this equation right here, that would be where your equation would land. So this is my final graph, the green graph. And I always like to personally name my graphs. So this graph will be Annie, the absolute value graph. It's a beautiful graph. Alright, so for part B, it's pretty much going to be the same kind of thing. So if you want to try part B on your own, it's a separate video, but if you want to try it without watching the video and then fast forward to the end, I encourage that you do that. Otherwise, you can go ahead and start part B. Have fun, you guys.